Hello and welcome back. Today we're going to be talking organic chemistry, or specifically hydrocarbons. Now, one thing to note is that hydrocarbons are made up of hydrogen and carbon only. There are no other elements in them. There are two main types of hydrocarbons, which are saturated hydrocarbons and unsaturated hydrocarbons. What's the difference between them? It's a pretty basic difference. Saturated hydrocarbons have have single covalent bonds only, whereas unsaturated hydrocarbons are going to have at least one double or one triple covalent bond. So saturated hydrocarbons, we've got two types. We've got an alkane and we've got a cycloalkane. So alkanes, the important thing to note about them is that they've got only single covalent bonds because obviously they're saturated, but it's an open chain, which means if you start at one end and you go, you're going to have an end point. Whereas cycloalkanes are what we call a closed chain. So cycloalkanes also have just single covalent bonds, but if you pick a point to start it and you just keep looping around, you're never going to come to an end. It's just going to keep going in a circle. That's what makes it a cycle or a cycloalkane. So alkenes are always going to have at least one carbon, but they could have more. Cycloalkanes have to have at least 3 carbons. Moving on to unsaturated hydrocarbons, we're just going to take two, which are alkene and alkyne. Alkenes have at least one double bond, and alkynes have at least one triple bond. We said that these are unsaturated, remember, which means that they have at least one double or at least one triple. But they don't have to have only one double or only one triple. If they have 2 doubles, they're an alkene. If they have 3 triples or 2 triples or a triple, they're alkynes. So alkenes need to have at least 2 carbons because to have a double bond, you need to have at least 2. You can't have a double bond with only 1 carbon because hydrogen only takes 1 bond. Same thing for alkynes. You have to have at least 2 carbons because it's the only way you can have a triple bond formed because hydrogens, again, can only take 1 bond. Now, alkanes are pretty easy to remember or to understand. You just need to remember the formula. CnH2n plus 2. This formula gives you the molecular formula for the alkanes. So if you have 1 carbon, or if n equals 1, the molecular formula is going to be CH4 because 2 times 1 is 2 plus 2 is 4. And we call that methane. If you have 2, it's going to be C2H6 and we call it ethane, and so on and so forth, as you can see here. What the important thing about this is to note that, see this ending, how it all ends with ane? That's because it's called alkane. This here, so it's always going to end with an ane if you're talking about an alkane. What's going to be different is the first part of the name. Methane is for 1, ethane is for 2 carbons, propane is for 3, butane for 4, and so on and so forth, all the way up to decane for 10. Which is just important to know because you're going to need to learn how to name compounds that are formed. There are also 2 types of alkanes in a way, or there's 2 structures, not necessarily only for alkanes, but especially used in alkanes in this lesson. And it's branched structure versus linear structure. We'll talk about this more when we talk about the isomers. But we're going to continue with alkenes and alkynes. So alkenes, as we said, have to have at least 2 carbon atoms, and they follow as long as there's only 1 double bond, they follow the formula CnH2n. So if you have 2 carbon atoms, the formula is going to be C2H4, and it's going to be called ethene because, like we said, it follows these names that I have highlighted in pink, but the ending is that of alkene, so ene. So 3 carbons is going to be propene, 4 carbons is going to be butene, and so on and so forth. Alkynes are really similar. They just have a slightly different formula, which is CnH2n minus 2. But again, similar to alkenes, this formula is only true while they have one triple bond. If they have 2 or 3 triple bonds, we can't apply this formula. And similar to the naming of alkene and alkane, it follows the structure of ethyne, propyne, butyne, ending with YNE and starting with one of, like, whichever corresponding one it is. On to isomers. Isomers, actually no, before isomers we need to talk about the different formulas. You can have a molecular formula, which is just where you list the number, like how many carbons are, how many hydrogens are. You can have structural formulas, which is where it shows every single bond. So this is really detailed. It's much more in-depth and it takes a bit more time. And you can have a condensed structural formula, which only shows the bonds between carbons, like you can see right here. This would be the molecular formula, this is the structural formula, and this is the condensed structural formula. Moving on to isomers. Isomers are compounds that have the same molecular formula, but a different structural formula. For example, let's work on, okay, let me explain how that's possible first. We have different structures, which are known as branched structure and linear structure. Branched structure is where a carbon might attach itself to more than 2 other carbons. Similar to here, you can see you've got a straight line and then a little branch coming off of it. Whereas linear structures are just going to be one straight chain where no carbon is attached to more than 2 other carbons. So going back to isomers, we're going to solve a quick problem just to properly illustrate the differences between them. We're going to discuss the isomers of, let's do maybe C5H12. This is an alkane because it follows the formula CnH2n plus 2. So when you're trying to draw isomers, always start with the basic linear formula. And I'm just going to draw these condensed structural formula because it takes too much time to draw them just pure structural formula, and I don't have time for that. So we're going to start CH3, CH2, 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 CH3. Excuse me. So if you want to make sure if your work is right, it's really easy. You just need to count how many you have. So I have 1, 2, 3, 4, 5 carbons. So C5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 12 hydrogens. So we can tell that this matches that. Now, what is the name of this compound? Well, we can go back to our table and remember that if we have 5 carbons, it's going to start with pent. So it's going to be pent. And we can see that we only have single covalent bonds, so it's going to be ane, pentane. So this is called pentane. Now, to draw out all the isomers, what you need to do is take off the last carbon that you have and move it around. In this case, we have, let me show you the isomers 1 second. So you take this that we have here, okay, and you move it. You have 1, 2, 3, 4 options for where to put it. However, those 4 options, you can't actually put them all there. This is because if you put it, let me show you. If you put it like this, CH3, CH2, 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 CH3. So if you move it to this extremity, the longest chain is going to be this whole entire thing, right? Because no carbon is connected to more than 2 carbons, which means this one is not an option. You can't put it there. Okay, let me move it to over here. Let me just write that out for you. It's going to look something like this. CH2, CH3, CH2, CH2, CH3. You can see that this is the same as this. This is the main chain. So this one also won't work. That means we have 2 options left. Let's start out by putting it here. So we start with the extremity, which is CH3, and then you move it CH. You're only going to put 1 H here because it's connected to 3 other carbons. CH2, CH3. bring this down, you get CH3, okay? So if you try and identify the main chain, you need to count what is the longest chain. So you have either option 1, 2, 3, 4, or 1, 2, 3, 4. They're both equal. So we're just gonna call this one here the longest chain. Now, excuse me, how do we name this chain? It's pretty easy. You start by identifying the main chain, which we did right here. Then you specify the position of the branch. So this is the branch right here. What number is it on from these? Now you could, if you start from here, it would be 1, 2, 3, it would be the third. Or if you start from here, it would be 1, 2, the second here. Now, we always want to take the smallest number possible, which in this case is 2. So we're going to call it 2. We're going to put a dash. Now, how many carbons are our branch? We have 1 carbon as our branch, so it's going to be meth. But then we need to add an ending to it. And because this is a branch, we're going to add the ending YL. So 2 methyl. And then we count the main chain, or we figure out what the main chain is, which in this case is butane, because there's 1, 2, 3, 4 carbons and only single chains. So it's going to be butane. So that is the name of this chain. Now, if we try and, so this one, we confirmed it works. Now if we try and move it to here, we get something that looks like this: CH3, CH2, CH, CH3, CH3. Can you tell why this might be right or why it might be wrong? Let's start. We're going to identify that this is the main chain, okay? And then we're going to count. We either have, let me write it in another color, 1, 2, 3, 4, or 1, 2, 3, 4. Sorry, 4 should be here. As I said, we always need to take the smallest branch that it's on, which in this case is 2. And again, we only have 1 branch, so we're going to call it methyl. And then again, it's just a 4, a simple 4, so it's butane. And we can observe that these two names, that pen does not work. Excuse me. We can see that these two are named the same, which means putting it here and putting it here doesn't make a difference. So how many total isomers do we have? This linear chain counts as 1, and one of these counts as 1. So we have 2 total isomers. Now let's try one more, but we're gonna do it with, let's see, C6H14. Again, we're gonna start with the linear chain, which is CH3, CH2, 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 1, 2, 3, 4, CH2, CH3. This is a pretty simple name, obviously. We just call it hexane. Now we can move on. We start by taking this one off, and we'll put it here, because remember, you can't put stuff on the extremities. So you can't put anything here, and you can't put anything here. So CH3, CH, CH2, CH2, CH3, and we're going to bring this down, CH3. Start as always by identifying the main chain, and then the branch is right here, so it's going to be, excuse me, 2 methyl, and then this here is pentane. It's pretty simple and obvious if you understood the last part. So this one, we can actually in this case move it over 1, because if we move it to here, this is not the second, like this is not in position 2, this is in position 3. If we move it, CH3, CH2, CH, CH2, CH3, and bring this down here, CH3, we can, of course, obviously, we're going to circle the main chain. And we are going to count 1, 2, 3. 1, 2, 3, it doesn't make a difference. We can count either way. So it's going to be 3 methyl pentane. Now, We can't move this one anywhere else because anywhere else we put it is going to have one of the same names as these. But one thing that we can do is we can take a whole other methyl. We can bring in a whole other methyl. So again, we're going to start by removing the extremities because you can't put it on the extremities. So you have two options for where to put this. You can put this here and you can put it here. We're going to start by putting it here. CH3, CH, CH, CH3, CH3, CH3. Here, the main chain is the one with the longest, which is 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. They're all the same, so it doesn't matter which one you take. I'm just going to take the linear one to make it easier. Now, here's where it gets a tiny bit confusing. You have a methyl on number 2 and you have a methyl on number 3. How do you name it? Well, you got the number 2, you got the number 3, and then you have two methyls. So you call them dimethyl. And then this is 1, 2, 3, 4, which is butane. So the name is 2,3-dimethyl butane. Now, if we put this one over here, it's going to look something like this. CH3 and then CH3, CH3. The main chain here is this one, just because it doesn't matter. And we can see that they're both on the number 2. So what do we do? 2, 2. Dimethyl butane. Now, if you try and move any one of these anywhere else, you're not going to be able to, because it'll just give you another one of these. So this one has 1, 2, 3, 4, 5 isomers. One important thing to note is that there's no relation found yet between the isomers and the formula, so just put that aside. Don't try and find a relation. There's one more case that we can do. I'm just going to write it out like this for you. Okay, what if you have something that looks like this? How would you name this? We're going to start by identifying the main chain. So we're just going to count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the main chain is either going to be this one or this one. So I'm just going to take the linear one to make it more clear. Now, here we've got what this is obviously a methyl, but then what's this? This one right here is like two methyls combined, but not really. What this is called is an ethyl. Ethyl because it's 2 in 1. It's like a 2-in-1 combination, you know? So how do we name it? When we write out the name, we always go alphabetically. So is E before M or is M before E? E is obviously before M, so we need to start with, so we need to keep the numbers as low as possible. So it's either going to be 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. So it doesn't really matter which one we can take. I'm going to take the ethyl is 3. So it's going to be 3 ethyl, comma, 2 methyl, and then this is 1, 2, 3, 4, 5, 6, which is hexane. So that is how you name and identify different organic compounds, specifically hydrocarbons.